Hi, in this video I'm going to be helping you with the second part of solving radical equations. This time we're dealing with cube roots. I want you to know the philosophy that we're going to use here. The steps that we're going to use are going to work for fourth roots and fifth roots and sixth roots as well, okay? So hopefully you'll do square roots and cube roots and you'll say, okay, I see the pattern here, Mr. Kisker. I can do the rest of these problems, okay? First step here is to get the thing with the radical sign, that would be the cube root of x, get it by itself. See, I've got the cube root of x, but I'm subtracting 4 from it, right? And that gives me 23. So my first step is to add 4 to both sides. And so I have the cube root of x is equal to 27. Now, how do I get rid of a cube root? I got rid of a square root in the previous video by squaring both sides. So it would make sense, if I'm going to get rid of a cube root, I need to cube both sides. So I'm going to raise both sides to the third power. And that's going to give me a gigantic number because I didn't think through this example before I typed it out. So I just need to go to my calculator and let's do 27 raised to the third power. Holy moly, that is 19,683. The reason you got such a big number is because I picked a dumb number or dumb equation to start off with, okay? 19,683. By the way, compare to this, right? That's just the square root of x minus 4 is equal to 23. You get 700 something. The cube root of 4, the cube root of x minus 4 is 23, gives you an even bigger number, right? So it's important to know the difference between the square root sign and the cube root sign and how to get rid of them because you get drastically different answers, right? Let's go through and check our solution, just make sure it works. If I take the cube root of 19,683 and I subtract 4, does that give me 23? Good process, because we're going to find out, like I said, that there will be values that don't work later on. We'll get into that, okay? Let's take 19,683, okay? Whoops. Let's take that value. Let's raise it to the 1/3 power. Use parentheses for the 1/3, right? That's cube rooting it. That gives me 27. So 27 minus 4, does that equal 23? I think you're going to see that it does, right? 23, does that indeed equal 23? Happy face, whatever sign you want. Hey, we know things work out. The answer is 19,683. One more. Okay, and then this video is done. Here I have a cube root. Remember, 1/3 power and cube root, that's the same thing, different ways of writing the same information. So I need to get this piece here, this chunk, by itself before I can actually cube both sides. So I need to add 2 first. Let's add 2 to both sides. That gives me x plus 4 raised to the 1/3 is equal to -6 plus 2, which is -4. Now I need to cube both sides. If I cube both sides, then I get just a straight x plus 4 on the left. I get -4 times -4 times -4 on the right. Be careful. Notice that I use parentheses around the -4, right? Because I'm cubing the entire side, okay? I'm going to type it in twice here. Ready? That's correct. -4, if I cube it, -4 times -4 times -4 gives me -64 because I got 3 negative values, okay? There's a tendency for people to type it in like this, -4 raised to the 3rd power, and you get, the same thing. Okay, you get lucky in this case, all right? But I want you to be careful that whenever you do these problems, it's actually the top way that's correct. We need to do the -4. My lights just went off in my room. Can you still see, I hope? There we go. You need to get the negative value out. We need to put parentheses around this because we're cubing the whole side. Now, one last step, we need to subtract 4 from both sides because I got x plus 4 on the left, and that gives me x is -68. Let's go through and check and make sure that it works. If I took, in the original equation, -68, and I added 4, cube rooted it, subtracted 2, would I get -6? That's the question. Well, if I took -68, and I added 4, I would get -64, right? So I'd have -64, cube root of that, minus 2. Is that equal to -6? -64, if I raise it to the 1/3 power, you see because of the glare, I'm going to take that and raise it to the 1/3 power. That gives me a -4. So this is really -4 minus 2. Is that equal to -6? And I think you can see that it is. And so we get a happy face here. We've checked it off. Everything works. The answer is -68. So you can see then the pattern is to get rid of square roots, I square both sides after I get the radical by itself. To get rid of cube roots, I cube both sides after I get rid of the radical by itself. So if you got a 4th root, get the radical by itself, raise both sides to the 4th power, so on and so forth. Okay, hopefully that pattern makes sense. That's going to be it for day 1. That should get you through a large chunk of the homework. In day 2, we're going to come back and do some more difficult problems involving extraneous solutions, those solutions I told you that we need to check because they don't always exist. And we're going to get into some more difficult problems when you have like 2 square root signs, one on either side of the equal sign. So there you go. You're ready to go now with the first day of homework on radical equations.